All right, 2.4. We're learning two more rules. We have the power rule. We have the sine and cosine rule. We're going to learn two rules, the product rule and the quotient rule. The product rule is going to be useful for finding the derivatives of two things that are what multiplied together, do you think? Multiplied. Product, multiplied. Amplified was close. A quotient rule is going to be used for finding the derivative of two functions that are what-ited? Divided. Good, divided. Sets you up for success. Now, before we start, it's worth just reminding you that we have a new function now. So that makes two. We have f of x, our old friend f of x. It's our y-value generating machine. It gives you the instantaneous position of something at an x value. But now we have its partner f prime of x, which gives us the instantaneous rate of change at that moment. So two functions give us one piece of, or they each give us one piece of information at a single instant in time, where it's at and how it's changing. Rather nice. All right, now the product rule is probably one of the most widely missed rules that students use. So I start off by giving you not the product rule, but the incorrect product rule. So as I show you the incorrect product rule, don't start thinking that this is how it actually works. This is how you do not want to do it. Here's the incorrect product rule stated correctly. The derivative with respect to x of f of x times g of x, that is a product of two variable functions. The incorrect product rule says it's just equal to f prime of x times g prime of x. You can just take the derivative of both factors and multiply them together. Now, if you want to help yourself, just scratch out the word incorrect and put a giant not equal sign there. That is not how you do it. Okay? Por ejemplo, if I have the derivative with respect to x of x squared times sine of x, that is a product of two variable functions. You see that? You got an x squared, that's a variable, times sine of x. Here's what it is not equal to. What's the derivative of x squared? 2x. The derivative of x squared is 2x. What's the derivative of sine? Cosine. The derivative of the entire function, though, is not 2x times cosine of x. It doesn't work that way. Now, had there been a little plus sign in between them, could you do it like that? Terms work. Term, boom, boom, boom down the line. Products? No, no, no. Okay? So that's the bad news. It's not that simple. But you know what? There's good news. And the good news is there is a way. And it's called either the correct product rule or, of course, simply just the product rule. And here's what it says. It says the derivative of f times g is f prime. Yes. But times g. Plus f now, who's already had his turn, times guess what? G prime. It's kind of like the trig identities for the composite, right? The selfless sign, me, you, me, you. Take turns. So you do take the derivative of both of those eventually, but they each get their own shining moment in their own term. And then the other guy, the other factor, he's just there watching for moral support. So, maybe encouraging him along the way. Here's a good way to kind of account for the problem. If you start with two factors, you're going to end up with how many terms? One term, two terms, right. Terms are separated by plus or minus. So if you start with two factors, you're going to generate with two terms. And it's really hard to mess up the product rule. In fact, this is like one of the ways to do it, but because multiplication is commutative, and addition is commutative, it's hard to mess it up if you're in the spirit of just taking turns, right? If you're in the spirit of taking turns, you shouldn't mess it up. Because you can take the derivative of the second one first if you'd like. And in the second term, just take the root of the first one and add them together. Doesn't really matter. Multiplication and addition are commutative. Two factors generate how many terms? Two. Let's come back up here and revisit this problem and see how we would do it correctly. X squared times sine of x is not equal to that, but apparently it is equal to the derivative of x squared is 2x times, not times cosine, that's the incorrect product rule. Sine of x just goes along for the ride, right? It was 2x's turn to go, right? Plus, now x squared just stands fast. And he goes, come on, Sine of X, it's your turn. I already did it. Wasn't that bad? You got this, Sine. Go, Sine. And Sine's like, would you be quiet, X squared? That is annoying. The derivative of sine is cosine. How many terms did I end up with? 1, 2 terms. And how many factors did I start with? 2. So you take the derivative 1 factor at a time per term. Guess what? If you had 3 factors to start with, guess how many terms you're going to have? 3. And in each term, you're just taking the derivative of one of them. That's the product rule. All right, let's try example 1. It says using the product rule. So when I walk up to g of x, I'm taking inventory of the problem. I'm like, oh, I see I have an x, that's a variable function, times the 5x minus 3x squared. That's another variable function. And those are being multiplied. Now, what I like to do personally, I like to add grouping symbols around my factors because it helps me see something times something. Here we go with the product rule, as the instructions stated. G prime, don't forget the all-important left side. What is the derivative of the first factor x? 1, right? The derivative of x is 1 times what? 5x minus 3x squared. Okay, good. We just rewrite the second one. Plus, now x gets rewritten times the derivative of 5x minus 3x squared, which is what? Yeah, 5 minus 6x, if you take it in order. So there you go. 2 factors generates 2 terms. And you only take the derivative 1 per term. Okay?
You know the x doesn't tag along with 5?
The x tag along with the 5? No, it's x here in the second term times the quantity. Now, oh, the 5x? Here?
No, over.
Here.
Yeah, where's it?
Well, I took the derivative. What's the derivative of 5x? 5. And then what's the derivative of negative 3x squared? You multiply, you get negative 6x to the first. Okay, so that's the derivative. The arrows point to the derivatives. 2 terms take turns. Terms, turns, right? Take turns. 2 terms. Now, if I wanted to use that, I would probably expand it to put it in a more user-friendly format. So let's distribute the 1. I could do that all day long. Yeah. And then distributing the x, not much more difficult. Plus 5x minus 6x squared. Yeah, so far so good. Now I spy some like terms, don't you? So let's combine them. 5x plus 5x makes 10x's, and then negative 3x squared minus 6x squared is negative 9x squared. So that's a nice cleaned up version of the derivative. Now, looking back to what I originally asked you to do. If I just asked you to find g prime and I left you to your own methods, could you do this problem, find g prime, before you came in today with any advanced knowledge of the product rule? Absolutely. You would have had to have done what first? Expand it out. X times 5x is 5x squared minus 3x cubed. So if you simplify early and often, it might help. Simplifying a little bit more on the front end can help on the back end, right? As they say, an ounce of prevention is worth a pound of cure. Right? That's like a 1 to 16 exchange rate. That's pretty good. G prime of x now, without the product rule, just the other rule, what's it called? The P rule, the power rule. What's the derivative of 5x squared? 10x. What's the derivative of negative 3x cubed? X squared. Is that the same thing we got down there? Yeah. And which way was easier, the second or the first? I think the second was easier. And even though I have the product rule in my tool bag, my arsenal of math tools or weapons, whatever, I don't know, I would still choose to expand it first and use the power rule. So why did we, yeah, go ahead. Well, if it's a free response, yeah, I'll be looking for the work. But if it was a multiple choice, I wouldn't tell you which method to use, or even if I did, how would I know if you didn't? Okay? So why would I do it 2 different ways? It's nice to have choices, but it's also nice to be able to verify that this new rule that we just got actually what? Works. It actually works. So now that you know that it works, you have full confidence in using it, right?
Yes, sir.
And you can go forth and be mathy. Well, people are packing up. I've done that once before, and I let you go based upon the sound of y'all wrestling, and it was way premature.
Because you were confident.
Yeah, yeah. But it is. We have about 20 seconds left. So on Thursday, we will learn the quotient rule very quickly, work one or two problems. You're not going to have anything more difficult than like x squared sine of x on the test, okay? And then we'll talk about what the test looks like, and then Friday we'll have the big party, okay?